Alright, next video is on McGraw-Hill Chapter 2, Section 6, which is Introduction to Functions. Definition of a function is really pretty simple. If you look at your ordered pairs, the x's cannot be repeated. So if you have any of your x's in your ordered pairs repeated, it's not a function, it's a relation. That's all there is to it. X's cannot be repeated. Looking at the first example here, looking at this, for instance, if we look at this first example here, letter A, see how the number 1 here, has two arrows coming from it. That means x is repeated. So this is not a function, this is a relation. See how one line from here, one line from here, one line from here? That means this is a function because my x's are not repeated. Same thing here. One line, one line, one line. It doesn't matter if I repeat my y's. I just cannot repeat my x's. Coming down here to an ordered pair. See how 1 is repeated? So therefore, this is not a function, it's a relation. We come over here, we have what we call the vertical line test. Vertical line test just means if I draw an infinite number of vertical lines on a graph, and it only intersects one point on the graph, then it is considered to be a function. So looking at here, okay, here's the ordered pairs we have here. First, by inspection on the ordered pairs, we can see that 1's repeated, so therefore it's not a function. Using the vertical line test, we can see that our vertical line right here is going through 2 points, so therefore not a function. We come over here, see how our x's are all different, so this is a function. See how if we do a vertical line test, the vertical line only goes through 1 point, so therefore a function. Looking here, here's a graph. If I draw vertical lines down, see how a bunch of my vertical lines are going to intersect 2 points? Therefore, this is not a function, it's a relation. Here, if I draw my vertical lines, see how all my vertical lines only intersect 1 point on the graph? This is a function. Coming over here, just looking at these two, this here is a function because all my vertical lines intersect 1 point on the graph. This is not a function. Just draw one vertical line through the graph and you're intersecting 1, 2, 3, 4 points. All right, then we come to example 3. Our function notation is always g of x, f of x, h of x, whatever. The letter here, this g, means nothing. It's just a name. It's like we all have names for people to understand. Like if someone has the name Bill and somebody calls out Bill, Bill turns his head. We say g of x. In this problem, we're talking about 1/2 x minus 1. They built this kind of notation because as you get higher up in math, you work with multiple equations. So you've got to be able to understand which equations you're working with. So we label them g of x, f of x, h of x, I of x, k of x, to know which one we're working. So this problem here, example 3, says evaluate for g of x equals 1/2 x minus 1. So remember, what we're going to do is we're going to take whatever x is, substitute it in here, and solve. So the first one, letter A, is g of 0. So I put 0 in for x, do the math, and I get -1. So this is my x, this is my y, so therefore my ordered pair is 0, -1. Second one, I'm looking for g of 2. So I put my 2 in there, do the math, I get 1 minus 1, which is 0. So my x is 2, y is 0, ordered pair is 2, 0. I'm in here, I'm looking for g of 4. So I put my 4 in here, I get 2 minus 1, which is 1. X is 4, y is 1, so 4, 1. So with -2, I get -1, which is -2. So negative 2 is x, negative 2 is y, so my ordered pair is -2, -2. Going to example 4. So that's dealing with numbers. When we substitute in numbers, gives us an ordered pair. This is dealing with algebra. So example 4 says, evaluate for f of x equaling x squared minus 2x, or g of x equals 3x plus 5. So the first problem says find f of t. So what I'm going to do is I'm going to take this t and put it in for all the x's here. I get t squared minus 2t. So here's my x, here's my y, here's my ordered pair. Next one wants g of w plus 4. So w plus 4 is taking the place of x here. It's got to take the place of x here. So I get 3 times w plus 4 plus 5. Distribute the 3. I get 3w plus 12 plus 5. 3w plus 7. 17. This is my x. This is my y. Ordered pair is w plus 4, comma, 3w plus 17. Then I'm looking for f of negative t. So I'm going to take negative t, put it in for x here, negative t, and put it in for x here, which gives me negative t squared minus 2 minus t. This gives me t squared plus 2t. So here's my x, here's my y, here's my ordered pair. Going to example 6, it says find the domain. Now, 2 things you got to worry about the domain. Number 1, if you don't have a denominator, it's all real numbers. If you have a denominator, the denominator can never be 0 because you can't have 0 on the bottom of a fraction. If you have a square root, inside the square root it can never be negative. It always has to be positive. That's how you find your domain. So here we have a denominator. We're going to take 2x minus 1, set it equals 0. We find out x equals 1/2. When x is 1/2, the bottom is 0. So our domain is coming from negative infinity to 1/2, parentheses, because we're not going to use 1/2, union, parentheses 1/2, because we're leaving 1/2, to positive infinity. This notation here says that we're coming from negative infinity, but we're not using 1/2. We're leaving 1/2 because we're not using it and going to positive infinity. Now, here we have a denominator, but the denominator we have an x squared plus 9. So no matter whether we put a positive number in here or a negative number, this bottom is always going to be positive. So this is all real numbers, negative infinity to positive infinity. Whenever we have a square root, we're going to take that what's inside the square root, set it greater than 0. Because that's what this has to be. This has to be greater than 0. So subtract the 4 over, we get t has to be greater than negative 4. No line underneath it, so it's a parentheses negative 4, comma, going to positive infinity. Because inside here, the radical must always be positive. So don't forget. Only 2 things I got to check. First, I look and see if I have a denominator. If I have a denominator, I got to set it equal to 0, and that x cannot be that value, or values. Second, I look to see if I have a square root. If I have a square root, I take what's inside the square root, set it greater than 0, solve, and that's where my interval starts and goes to positive infinity. If I do not have a denominator, it's all real numbers. Or if I have a denominator that's always going to be positive, it's all real numbers. Last thing I want to show you, and I have to do this from a book because I don't necessarily, my drawings would be terrible. This one here says, consider the function pictured in figure 2-34. Here it is right here. Okay. And so what it's asking is, it's going to ask us some questions, and we're going to use the graph to determine the answer. So first of all, it says find h of negative 1. Well, negative 1 is x. So we come over here to the graph when we find negative 1. If I move up, I can see that h of negative 1 is equal to 2. So that's what we're doing. We're going to go back and forth from y to x. Letter B says find h of 2. So I'm coming over here. 2 is x. Move up. H of 2 equals 1. Over here, saying find h of 5. I'm coming over here. Here's h of 5. There is no value for h of 5. So it's an open point. So we don't have a value for h of 5. It's not defined. There needs to be a point there if we want a value for here. So this h of 5 is undefined. All right, then we work in reverse. So it says, for what value of x is h of x equals 3? Okay, anytime you see h of x, g of x, f of x, this is really y. It's really y. So this is really saying y equals 3. So when I come over here, I'm going to find 3 on the y-axis, move over here to the graph, move down, and I can see y of 3, x is negative 4. So actually this answer here would be negative 4 for x, and then 3 for y, because here we're working reverse. This says h of x 0, so remember the h of x is y. So this is saying y equals 0. So we come over here, we find 0 for y, move up, and we see that 0 for y is about, I'm going to say a half, 1 1/2. So 3 halves. So this ordered pair here becomes 3 halves, 0. And that's all there is to it. Any questions?